If I had a student that was struggling with rounding, here's what I would do. First, make it hands-on. Second, draw a picture. And when they're really good at those two steps, finally, third, I would move on to those abstract rules that we learned growing up. Now, that whole process might take 5 minutes. It might take 5 days, depending on the kid. But here's what I'm talking about. First, make it hands-on. I have 4 piles of Oreos here. 10, 10, 10, and then a few more. So I might put this in front of my kid and say, how many Oreos do we have to the nearest 10th? Well, we know that we have 10, 20, 30, and then we have some more. So the question is really, am I closer to having 30 Oreos or completing this pile and having 40? Well, let's see, how many do we have here? 1, 6, 7. So I'm only 3 away from completing this pile. So I could say that having 37 Oreos is closer to having 40 than if I was to take that away and only have 30. And if they felt good with that, I might take some of these away. So what about now? Are we closer to having 30 or having 40 Oreos? And if they're doing good, put it right in the middle. 35 Oreos, what are we closer to, 30 or 40? And we can start to have a good discussion about that. It's right in the middle. So mathematicians have just decided that once you get up to 35, we could round that up to 40 Oreos. So there's a few skills that we want to make sure that they have here. First, they have to know if I was to take this entire stack away, how many Oreos are there? 30. Next, if I was to complete this stack, we want them to know that that would be 40 Oreos. And then finally, what's the midpoint between 30 and 40? 35. So anything smaller than this sends us down to 30 Oreos. Anything larger than this sends us up to 40. Now, if they're doing good here and they understand the idea, then I'm going to say, okay, let's take the Oreos away and let's draw this on a number line.